This is lab 18, part 3, so where we're going to have a combination circuit. So what you're going to do is you're going to set up your circuit board like this, where you have two circuits, A and B, which are in parallel, and then our other circuit, which is in series. One important thing to note when you're setting up the circuits is that if you have parallel, you need to make sure that on these rows of 5, the starting circuit and your two parallel wires are all in the same row, and then same when you have the ending. So your parallel circuits are going to be in the same row of 5, and then the beginning of your circuit, which is in series, is going to be in the same row of 5. And then again at the end, these two are going to be in the same row. Therefore, the electricity flows from the power source through the wire to here, to here, to here, and out. Is basically going to be the setup of the circuit. So the first thing that you're going to do is you are going to measure the voltage of the system. We're going to turn on our power supply. Make sure that's all set up. We're going to set it to about 1 volt running through the system, and the current should be about like 0.01 amps, so very low. The next thing we're going to do is we're going to take our voltmeter and we're going to set it to one wire in the common slot and another wire in the voltage / ohm slot, and making sure this dial is turned to volts. Probably around 20 was usually where we got the best readings from. In order to measure the total voltage of the system, you can either put your little wires attached to the voltmeter here. This one's not working very well. Here and here. Or if you want, you can also do it to here, the very first resistor and the last resistor. It's however you want to do it. And then you're going to take the voltage of that. And then you're going to do the same for each of the resistors. You're going to put it at the beginning of the resistor and also the end of the resistor, and that'll show a new voltage. We're going to move it to B, take our new voltage, which should be the same since they're in series, or sorry, they're in parallel, and then we're going to measure the one that's in series, C, and he should probably be different because he's in series. And then we're going to measure the resistance. So for the resistance, we're going to continue to have this in the first slots, but we're going to move this dial down to measure resistance. So we're going to change it to ohms, probably around here. And then what we're going to do is we're actually going to disconnect the power. And in order to measure the resistance of the entire circuit, we're going to put the clips at the beginning and the end of our circuit, and that should give us a resistance. And then we're going to do the same for each of the resistors. We're just going to take them out of the circuit entirely and measure the resistance. And then we're going to do the same for each of the resistors. We're going to take them out individually and measure them and write them down. And this should all be in Excel.
And then to get the
to organize
current.
it. And then to get the current. This is the most complicated one. So if you're watching this, this is the part where we will need to pay attention closely. You're going to take a third small wire. And in order to break the current of a system, you're going to break the system at that point so that the system is now running through the current meter, or the ammeter now. So we're going to change this, first of all, to measure amps. We're going to put this probably on here. I can turn the power back on now that it's not screaming at me. So it's important that this is set on amps, probably at about 2 milliamps.
So she moved one of the wires from ohms to amps,
And it's
and then she
micro
changed,
amps, not 20 amps too.
yeah, and she changed the dial over to amps.
Yes, so they match up. Then what you're going to do is to measure the the current of the entire system. We're going to break the system right here, right where the power supply attaches to our circuit board. So we're going to take this wire out, and this red wire came from this very first hole in this row of 5. So I'm going to take this new green wire and put it in the exact same hole that it came from originally, the exact same one. And then I'm going to take this side of the clip and put it onto the green wire, and this side of the clip, and since this isn't really going to do much good, I'm actually going to clip it.
I want to show.
Yes. The exact
The one
connection.
going to the green wire is the one that was in the amp spot, and the one that was in the common spot is now going to the main power source.
Yes. And so now what's going to happen is our power source is going to run through this wire, through our ammeter, out the ammeter, through this green wire, and then back through the circuit. So it completes the circuit. It's just taking a detour through the ammeter.
And then that'll spit out a number for you.
Yep. And then we're going to fix our circuit and measure the next one. I'm going to take this out, put this exactly where it came from, put our power supply back, and then we're going to break it again at another point. We're going to break it at the beginning of resistor A. So we're going to take resistor A out. We're going to put the green wire in.
Only take resistor A out on one
Yes,
side.
only on one side, that's true. This side should still be in. We are going to clip the ammeter onto the green wire, and the other side of the ammeter,
She took that from the one that was on the common spot.
yes, although I don't think it actually matters which side as long as they're both connected. And then we're going to clip the other side of the ammeter to the resistor. So now this completes the circuit again, and we have a new measurement. And then you do that for all of the resistors.
By doing that, she was isolating just the one resistor that we
Yes,
pulled
just the
out.
one resistor.
And then for parts 1 and 2, in parts 1, it's literally just the same exact things we did here, but all 3 of them will be in parallel where they're in the same row.
We
And-
can actually just do that right now. We'll just move this dude
They'll be like that,
right here.
and then
And then this will
accepting
also
one
be in that
be
same
in
row.
that spot, and then you do the calculation. You calculate the total and the individuals exactly as we just showed you, and then in part 2, you do all 3 of them
In
in
series. Which is a little bit complicated, so I'll do that too. Basically, we're just going to...
So, where one of them went out, next one attaches, and then these ones are going to be in the same row, and these ones are going to be in the same row, and that's in the same row. And that is what the series looks like. And then you calculate the total and individuals, same as we showed for part 3.
Yes.